I'm Gözde Tuzcu. I have a background on material science. I did a PhD in Technical University of Eindhoven on thermoplastic elastomers, and then I started working as a consultant and also as an expert for certification in Kiwa. We are located in Rijswijk, and today I will just tell you about mainly I will start with standardization and continuous certification. So first of all, I will tell you about our company, maybe. Kiwa is a TIC company, so testing, inspection, and certification company. We are busy with many different markets, as you see on the right-hand side. And we do certifications, testings. We have labs all around the world, and we do inspections. On-site or remote inspections. Already now in the outbreak time, the remote inspections got very important, so we try to also develop techniques to make tests or witnessings or inspections from a remote way. And so we have technical committees, and we follow up the committees for standardizations. We write guidelines, but also we do research, and we also do training. And we are basically active in those areas. That is also in the background. I look like a weather news presenter, but okay. And so I will continue with what are the activities in the standardization. In the standardization, in the ISO committee, this is ISO TC438. And these are, they are collaborating with ASTM F42, and EN is following those two and generally adapting the norms as an EN norm. So I think this is one of the rare examples of standardization committee where all EN, ISO, and ASTM work together. And in Netherlands, we have a mirror committee that is NC 34117. That's the Dutch committee. We are like not very many people, but we come together every year, twice a year, to discuss the activities related to the standardization also in Netherlands. In ISO, this information I got from the ISO website. So currently now there are 15 published ISO standards on additive manufacturing. So and 30 of them is still under development, and there are many people working together on those standards. And in total there are 8 different working groups. This is under these working groups there are many more joint working groups. So in average, every working group has maybe 10 subgroups under it, busy with writing the standards. I am trying to follow them as much as possible, but you cannot follow or actively participate in all of them. But I will give you some examples of the norms that they are working on, so then you have an idea of what kind of standards are actually currently are hot, and the people are trying to publish those standards. So first of all, especially the qualifications on additive manufacturing is now is a important topic. So this is a bit very texty slide, but I will just you can just have a look how wide it's the specifications, the standards for the specifications are. For example, already in 2017, a paper, a standard is published for the requirements of purchase ampers, which is very to the application oriented, let's say. But there are also very detailed specifications on test methods for like sand mold for metal casting, for example, which you see in the bottom of the list. So some of them has dates, so which means that they are already published, and some of them has some letters, which corresponds to the stages of the publication of the standard. So not all of them are public. So mainly this stage is something that is mostly public, but the working draft, for example, with an abbreviation of WD or CD, the committee draft is mostly, they are not public, that you cannot see them in advance before it's published. But when you are a member of the ISO committees, then you get access to all of these norms that which are still under development. So then you see what's actually going on from a technical point of view in the standardization. And so these are some examples of the requirements or the specifications for the test methods and the quality specifications. I will pass this slide now, and because I want to talk also for different ones. And some other working groups, for example, the environmental health and safety, these guys are also busy with the safety aspects of the 3D printing, with the safety of the machines or safety of the personnel, that kind of topics that they are trying to cover. So there are also very interesting discussions going on during the meetings, the committee meetings. And for example, also another group which is work group 10, and they are writing the standards which are specific to the aerospace applications. Especially there are so much demand from aviation, from civil aviation, that then they want to use parts, 3D printed parts to lower the costs as well, but always the quality or the safety of the parts are very important. So then they want to write some specifications or requirements for the parts in those kind of applications. And the surgical implant applications, for example, this is also one of the most very important application where the 3D printing is used. But they need also, because it's a medical application, and it's especially it's an implant which is used in the body, so there are also many requirements to make them applicable in the market. But for example, here I want to also give you an example. The standards are written in the plastic group. The working group 11, they do the standards for the plastic applications. These are the norms that they are now working on. Some of them are already published, and some of them are in this stage or working draft stage. So this is, for example, what I want to tell you here, that the last three norms that you see, which is about the material extrusion based additive manufacturing of plastics. So the first two, the feedstock materials and the equipment, the requirements for feedstock materials and equipment, they are already published, either as at this stage or as a final stage. But the third one, the specifications for the final parts, I have the CD version of it, but it didn't continue. It's discontinued, so it didn't published as a standard at the end. I missed why it was so, but it was, for me, it is very interesting for me from a certification point of view to get a specification for the final part. But it was, for example, discontinued, and I actually missed the discussions about it. But I think the standards, they really try to make something workable or useful for the 3D printing world. Because if the standard becomes so much retarding, or so much becomes the kind of tackling point in the way of development of the 3D printing, then it's generally discontinued. So because it's kind of limiting the developments or limiting the techniques in the 3D printing, then they don't continue it anymore. So it's, from that point of view, people are very aware that the published standards should be useful and helpful for the developments in the 3D printing, because 3D printing is a very flexible and still very innovative in, how do you say, systems. They have those kind of systems to which shouldn't be limited by the standards and the requirements or specifications, which, so that's we also try to support from this point of view, the 3D printing world, to understand the dynamics of it and try to help up for the market acceptance and for the for the quality assurance, let's say, to have a nice and applicable techniques to be able to assess or standardize the techniques. So I will also go out from this slide, and I think this is all for the standard part that I want to tell. It's they are busy with many things and busy with many standards, and people are the experts and the other stakeholders, related people, they are always welcome to get into action in these standards with new also new working items. That's what I wanted to say from the standardization point of view, and from certification point of view, because when you have the standards as a tool to assess or to improve the market acceptance of the products, the certification is a tool to be able to independently assess the quality or the safety of the product, and to go further for the market acceptance of the products or of the processes, and to also improve the communication, the effectivity of the communication between the companies, to make a common language among all of the producers and the users, and to make things a bit faster and efficient, in my opinion. And especially in the outbreak, we see that like 3D printing is very important tool to come up to answer the needs of the situation, but there were limitations from the safety point of view, or from the quality or the functionality point of view, to prove that the product really serves what it is doing. So that's, as Kiwa, we try to fill this gap. So we know that the 3D printing is working very hard to find much better techniques and more reliable products and so on. But to show it to the market is it needs a kind of independent assessment and an efficient method to assess those products. And it's Kiwa, we work from this point of view in two different ways. One is the traditional way, which is via, we call it collective assessment guidelines. So a group of people who are interested on the same product or on the same application, they come together, and with the help of us, we write all together a guideline to assess that product. And then this becomes, in Dutch we call it DRL. So, and then we give certification based on this guideline. This is the traditional way of certification. And the other one is what we use for more flexible techniques, for flexible manufacturing methods like 3D printing. We call it bipartite certification. So it's a Kiwa covenant, and it's actually I can say that it's a kind of custom covenant, which you this is only with Kiwa and with the producer or with the retailer, let's say. In there, the certification holder, they tell you what the scope of their product is, or what they want to show as an aspect of the product, and then we write a kind of a custom guideline specific to that product, and we just do the assessments and analysis or whatever needed on the product, and then we give a certificate for it. So that's generally for 3D printing or for additive manufacturing techniques. This is we see that this is much more relevant, because it's generally, because there are so many different types of techniques and so many different types of applications. So writing a collective guideline is generally much more work than for its purpose, let's say, or the level of the additive manufacturing is not yet there to have those kind of big production and wide how do you say application wide applications to get to have the a collective guideline for multiple people. So that's why we are mostly working on the bipartite covenants. That's what I can say about this. For example, in this one, I want to go a bit into detail of what is possible. This is also very parallel to the works in the ISO, because there are so many specifications on the process, on persons that are busy with the additive manufacturing and some aspects. So these are all can be certified as well. So there are many different contents of certification, and there is many different ways of writing it, from requirement point of view or from a specification point of view, and that's what we are trying to help the companies to get into the market from a more safe and reliable point of view. So I think that's all what I want to say. Then I can maybe in the next minutes I can tell you about more if you have any more questions. Thank you for your attention, and this is my mail address. If you want to continue, if you want to contact with me from further discussions on standardization or in certification, I would love to hear it. Thank you.
Okay, thank you very much, Gözde, for your explanation about standardization and certification. Very interesting, and also a topic which is very often far away from many companies.
Yeah, so, from research especially, yeah.
if I'm a company, let's say, with materials, then I can let's say ask you to certify it, or can I be involved in the standardization of, let's say, polyurethane materials, something like that? Is that the idea?
Oh, I didn't get it.
Well, when are you using, let's say, certification? If I have a production facility and I want to, let's say, have a stamp that I'm a good producer or something, then I come and ask for certification. Is that the idea?
Yeah, exactly. Yeah, like if you have a product or a process, or because for example we also certify the aspects. For example, or processes. You even don't need to have a product.
Okay.
It's but you have, if you want to show something to the market that your product has this specification or has these properties, we make together with a guideline to independently assess it, and then do all the procedures to the testing of the products, and then maybe visiting the factory or whatever is needed. It totally depends on the scope of what we are certifying.
Yeah.
And yeah, that goes in this way. So
Okay.
so that's why, like, we try to adapt the flexible nature of additive manufacturing, because like waiting for a guideline from a collective point of view, it takes so long time to really bring up everybody to on the same level. So it's generally then now, from a practical point of view, it's much easier to work in this way.